Okay, Navit, hello. We'll get started and continue our discussion with electromagnetic induction.
No, bro. Wait, how far are
So
you?
till now we have talked about
Billion
three
star.
key ideas. Hopefully,
Bro,
my
how they look?
pen works.
The bakery is like right
The
there.
first idea we talked about was the fact
writing
that
out.
current carrying inductors uh, produce
Wait,
a
I'm not
B
sure we can
field
walk
around them,
there.
right? And
This is
that
the
the B
this is
field
the
is given by the right hand rule. The
freeway.
second idea that we talked about is if there is a current carrying
the
conductor
direction.
uh, inside a B field,
Ben Solo.
right? In that case, according to the left-hand rule, this experiences a force, right?
Oh,
Depending on
you
the
have to take
direction
a
of the current, this
ferry.
will experience a force,
Ah.
right? Then an extension of this idea is what we saw.
Oh, dude, the
That
ferry
there's a
probably be
B
cheaper.
field here again, but then now
Actually,
instead
that
of
might not
this
be
thing,
true.
there's a charge that's moving. That charge will now move in a circle,
Wow. And
right? Something like that.
why not just take the ferry?
Yeah, in this case, the force is like this.
Wait, is it like a ferry
So
tour?
force was QEB here, and force was IPL here. Direction is always given by the left-hand rule. And this was the second
Yeah.
topic that we
Did you say
discussed,
that, there's,
right? Uh,
you know,
so now we're going to discuss the
raincoats?
third key idea
Yeah,
in
exactly.
magnetism,
We gotta
which is this
experience
idea of induction,
fully
right?
experience.
So
We
if you
gotta go
remember
to the
from
max,
last
right?
year,
That
if
means we
you
can get
have,
weight.
say, a coil and you
Yeah,
start
that's
moving and say it is attached to, say, a bulb, right? And you have a magnet. And this magnet is moving in and out, right? Magnet is moving, maybe you're moving this toward, and what you see is current starts to flow here.
Oh my god. Yeah, it's sick.
Right? So something like
What is sick? Is it
uh,
right here? Is it right here?
something like what is shown
Walk
here.
left, right there.
Uh, so if so, the direction of the induced direction is given by what we call Lenz's law,
Oh,
as you will see in this chapter.
why did I think Magoo was like open
Uh,
to
and this
the
whole
ocean?
idea is called electromagnetic induction.
No, that's like a
Right. So we are going
like a
to see
bay.
more applications and more things, and it's related to what we call flux
No,
change
it's an ocean. They're called the ocean, right? It's not a
associated with the
bay.
loop.
Yeah, point proven.
So that induces a voltage,
This is
and that is what lights up
hmm.
the bulb. Okay, so let's talk about these things in a little more detail according to the book. I'm just going through these things. So the first thing
Yeah.
is, say if you have a motor and that's not
So
being
I'm
powered
sorry.
by
Do
a
you
battery,
call
and say
this the
you turn the
San
motor,
Francisco
then you see
Ocean
that it will
or San
cause a reading on the
Francisco
voltmeter,
Bay?
right? So that tells you something like,
No, I'm talking about
oh, you're
this part
trying to
right here.
move the magnets inside,
Hey,
or you're changing the flux inside,
I
and that
think
will
that's called
induce
San
this thing.
Francisco Bay.
Another way is what we
Oh,
talked about: have a coil
what is that?
and just move magnet in
Oh,
and out, right? Which is the experiment
I don't
number
see the
two
word
here,
ocean anywhere near here.
right?
Interesting.
And
Google did, and Google's always right.
yeah, um,
Wait, what
so
are
what
these?
we see here are things like
Walking, up,
the
up.
strength of the
No,
current
it's actually
that is
Golden Gate.
induced,
I'm
right?
sorry.
Depends on these things. So if it's
Why is
just
that
a
called
straight
Golden
wire,
Gate?
and say if
Wait, have you guys been
it's
to
a
this
coil of
lighthouse?
wire, right? In that experiment,
Looks really lame, actually.
and you're trying to move a magnet in, so the amount of voltage that is generated between these, right? The induced EMF, we call it.
Wait,
So that
oh,
depends on the magnitude of the magnetic flux density. So this is the B value. This is the
okay.
B value of the magnet.
Okay, you tell me. Oh,
So
I
what
see
is
it.
the B value at this point? What's the magnetic field at this point?
Oh,
It will
this looks
depend
like
on
a
that.
ramp of a
It
trireme.
depends on the area of cross section,
That's
right? Then it depends on the
trireme?
angle between the planes. So the magnetic field is going here, and in this case, area vector is going here, right? Like this is the phase, so area vector is going here. So it will also depend on the angle between
No!
number of turns of
Roman!
wire. So like
Read. Viking!
1, 2,
But
3, 4, 5, 6. Oops, so
no,
I
it's
guess
more,
6 here.
no,
The
Viking
number of
ship is like
turns. and yeah, in
Wait.
this case, where if the coil
Sorry,
is
hold on.
turning in the field, then
You
the
built a
rate is
submarine.
destroyed. We will see
Oh,
this
wait.
last point a little bit
Wait.
later.
Whoops.
But
There
the
we
main
go.
idea is it depends on B is
There's
important
no RAM, bro.
and A is important and angle is important.
What is this?
Right, so if you increase the
This is
area
not
in
the
the field,
correct one.
then the magnetic
This is
flux
that's a
associated,
dragon.
the amount of
It's not a
EMF
RAM.
induced will be more.
It's a
Okay.
stretch concentrator is what it is.
Uh, so okay.
What? It's not a RAM.
Yeah.
No, this is arguing. Oh wow, I didn't know the Viking has speedboats. Maybe that's why they were. Yeah, maybe that's why they were such successful raiders.
Okay. So the
This
first thing
story
to
might
think
have
about, so we now
inspired
start to think
such.
about the underlying reason, which is what we call the magnetic flux of the loop. The flux is a quantity that we define, right? So it is a
What?
representation of the number of field lines that pass
What the fuck? Oh, okay.
yeah,
Like,
sorry about that. That
okay,
pass
I just
through a loop, right?
Then we
That's
have to
the
sync
key.
it? I don't think we need a sounder.
That's the main idea.
I can do the sounding there.
Sorry about that.
Where's my whistling?
Let's continue.
What the fuck is this?
So this magnet in this case is stationary, right? It is placed here. So the magnetic field lines are going out and coming back
Oh,
out.
wait, yeah, you're. No, sick, that's
Right.
only
So what we
13.
can see is if this is the loop that you have, right? Like so, from the top view, it looks like magnet is somewhere here. Give me one more second. I'm getting this.
Oh, Monster Truck, no, Tom Truck. Wait for it. Wii U, tuck, tuck, tuck.
Uh, so mm, yeah, so you have a loop here. So imagine that the magnetic field lines that are going inside the loop and are coming out on the other
Here we
side,
go.
right?
You just run over everything.
Right. So they go
Oh
inside
my
the
god,
loop
dude,
and come
Ancient
out. So
Empire and
so
their
that is what the flux associated with the loop is, right? How many lines are
yep,
passing through the loop,
Ancient Empires and the cheat
right?
codes, man. Oh
So
my
if you
god.
have a bigger area, then the flux associated with the loop changes. If you have bigger B field, so that means more of these lines are coming out, right? Then also the flux increases,
Holy shit.
right? And if you placed it perpendicular, right? If your loop is
Yeah,
placed
yeah.
like
Oh,
this,
it's the fog
if
of
your area
war.
vector is like this and the flux lines that are coming out of the magnets are like
No,
this, right?
that's
So in a way
that's
that
what
they
it's
don't go
called,
through
dude.
the loop at all in this case. So here the flux is zero,
That's what the strategy
but
is.
here
That's what
you
it's
have a
called,
flux.
fog of war.
So flux is kind of like an angle dependent thing also. So angle, if they're aligned, right, then flux
Yeah.
is high.
You can't. The truck is so high, so lifted, you can't see past your
Right?
dashboard, right? Your
Okay.
windshield. So yeah.
Uh, so that's the basic idea.
No, I have to feedback. You feel them.
Okay. So next thing is the Fleming's right hand rule. So let's talk about that a little bit.
Yeah. It's same vibe, man. Same vibe.
So for a single conductor, when that is moving, right? So a useful thing is to follow the right hand rule. So the idea is if there is a wire initially, right? That is connected to say a bulb and has no battery,
My God,
right? And the wire is
this is
moving
so
down,
insane. What the?
right? It is dropping down, and the current and the magnetic field is going from north to south, right? So it is dropping down. Then you use the right hand now, where thumb is your motion, because thumb was originally the force in the left hand, and this is the motion. So point that down, that your B field points this way, and so your induced current, your middle finger gives you the induced current. That tells
Where?
you that it will flow
Ouija board?
along this line from here inwards, from here outwards. Right, so that means from here up inwards, from here outwards. That tells you the direction of the current. So this right hand rule gives you the direction of induced current. Right, so we discussed these concepts last year also. I'm just going through these a little bit faster than usual. Okay. Okay. So as we talked about the flux, let's take a step back here. So the flux is written as a formula.
Yeah. What?
Right. So that flux is written by phi, and as I said, that depended on B and A
Did you tell them that Aldo can also have to
into
do the
cos
work
of theta, where
for the
theta is
hours?
the angle between. So here theta is, this is A, and this is B vector, right? So angle is 90 here. Here A vector is downwards and B vector is also downwards. That is maximum, right? So cos theta into, if there are multiple say loops here, then you also multiply by a factor of say number of loops here. So that's your flux. Right? So that's your critical concept here. Understand? Okay.
What?
Fine.
Wow.
Just take your time to understand these things. The unit of flux is called Webers. Right, so that's another thing to keep in mind. Try attempting these questions that you have. It will help you your their understanding.
We're not gonna go to a different country
Okay.
to go to the shop.
So now that we have established what flux is basically how many lines are passing through the thing. Its formula is given by NBA cos theta.
Oh yeah. Yeah,
Right?
yes.
Now what we know is the EMF that's induced.
So there's your problem, right?
Right. So this is the induced EMF.
One is AC, one is not.
Is given by minus of the rate of change of this flux. So this is the rate of change of flux. So the idea is these two are same. Right. So if we see now, so this is the main formula. Like just now trying to think. So NBA cos theta. Any of these factors can change. N can change. N generally does not change. B can change. Like so, if you take the magnet far away, so B changes. On bit closer, then B changes. Area, right? Like so, area is like say if you're shrinking something or expanding. So one of the example for this is say if you have a railing. And you have say a fixed wire. This is a conductive railing. And then this is a fixed wire. Then say you have another wire that's like that can slide along this railing up and down, right? And imagine that there is magnetic field say going into the plane of the paper, right? And you are moving now. You're moving this free wire to the right. So then this loop that is formed, so that this area is changing, right? So that means the flux is here with this loop is changing. So that A can change, as we talked about. B can change in that scenario where you move a magnet closer and farther, and theta can also change. Right, theta changes when so imagine that magnetic field is like this, and you're rotating the loop like this. But so right now all of the flux is going, but when loop loop
Wait,
say rotates like this,
what's
there is no
stationary?
flux going inside the loop. So that is the key concept, right? And if any of these change, then
Bro, I'm
the
looking
flux
at the
associated with the loop changes,
photos,
so an EMF will be
and none of
induced.
these things have fucking socks.
Okay.
Uh,
Okay, so attempt these
bro,
questions. It will make sense to you
fucking
once you try
tote
it. Once you
bag,
start doing this
like
question, this
fucking
represents the
suckling.
change of
I don't see a
area question,
goddamn pen
right?
anywhere.
And yeah, so just think about this a little bit.
It's like
Okay.
fucking everything but. Oh my
Another
goodness.
concept is the direction of this thing. So we talked about how the
Yeah,
left hand
one
rule
station in the
right
stationary.
hand rule allows us to know the
Okay,
direction when a
okay.
single wire is moving, right? But in general, Lenz's law states that
Can you come back home?
induced things, uh,
Okay, we can check
induced
this out.
EMF
I would, I
opposes
would
the
love to try
source.
something.
Thus, this sentence is not accurate. Like I'm just trying to simplify it a little bit. What that means is if there's a magnet here and you're trying to move the magnet closer, right? So you want to oppose this magnet. So what you want to create in principle is another north here, so that this is opposed,
Okay,
right? So the
bye.
current flows in such a way that this pole here, right? So this when the current starts flowing,
Ben
it will
Tall
produce its
Center.
own magnetic field, right?
Why is he so tall?
It's reverse magnetic field. So it wants to produce field in a way.
Dude,
This goes out
what is this?
from here
Wow,
and comes back in from the other side,
I hate
so that
this.
it acts like
I
a magnet itself in a right because current is
this
being
is not English
induced.
basic.
That
What
will
the
produce
fuck
a
is
B
this?
field, B induced field, and that induced field should look like the one that is
This is
produced by the north pole of the magnet.
this feels like a hate
But on the
crime.
other hand, if you move it away, right, that then the opposite happens, and the
What
B
the
field is
fuck?
produced from the other side, such that this is the south pole and
Is
then
it
this is the
actually?
north. Right, because now it's going away and you want to pull it back, right? Form an attractive force. If you create a south pole here, you'll try to create an attraction
Yeah.
force from this,
Yeah, no, I hate
right?
that.
So
Okay.
whatever, so you want to induce
English
such
base.
that it opposes the
Is this why they drowned the English?
external force or external motion. So if the
What?
motion is towards you, that means you try to oppose. So I generate a north here.
Saying
If it
actually
goes away,
that's
then
when
generate a
the
south
T is
here to pull it
actually
back, right? So that's the key idea. Well, that helps you try to
well,
understand how the current
don't jump
should
the gun
be
saying I'm
induced.
getting there.
And so this is what
I'm getting there,
this
dude.
example talks about. I'm going through things a little bit fast. I highly encourage you to read the book
You gotta feel
and
the
just slow
distance.
things down a little.
Where's Massachusetts, by the way? Ah, oh, here is where they spill the
Okay.
tea.
Okay,
Yeah,
and the last thing that
the
I
biggest,
want to
the
talk
biggest
about,
tea. Well,
and this
actually, I don't
is
know where
this
in
concept
Boston.
of generators.
Is it
So we
here?
talked about how
That looks like
theta
a
can
teacup.
change. So in generators, what happens is you rotate a loop artificially, right?
Pleasure
And the B
Bay.
field is kept
Oh,
constant,
I
so
hate
theta
that name
changes,
too.
and because of theta, the induced current that's
Oh,
in the field in the loop changes.
the
So
tea.
let me talk about that a little bit more. The B field is constant, right? And you have a loop,
Okay, so we
right?
narrow it down to
So right now this loop is connected to a bulb,
uh,
right? And the
yeah.
bulb is not glowing because flux is
Where is it? Is the
zero
Boston
in
Harvest?
this case. In other scenario, right, B field is
Oh, we should
same,
check out some museum over there.
but this thing,
Maritime Museum. Oh,
right, is
okay.
perpendicular now, right? And it is still connected to the same bulb. The bulb is still not glowing because even though the flux is there, flux is not zero. Here flux is zero, but d phi by dt is zero,
What the fuck?
right? Like flux is not changing, but it's stationary loop. Here also d phi by dt is changing. It's also stationary. But if you start turning it by
Museum
some
for
mechanism, say from the other side you attach say
Why
a
does everything look like a fucking
rod and
spaceship to
start
me?
turning it, right? So then the
What-
flux associated with
What's
this
up?
loop
Oh,
changes, and because
that's
of which a current starts to flow, right? So d phi by dt changes, and what changes is
I'm not gonna lie. I think I'm
NAB
gonna take a picture of the
cos
whole
by
museum.
theta.
Put it on
So cos
Google Maps.
theta,
That's the part of
this
it.
theta changes to cos theta. Everything else remains the same. So this is why this is
I
called
already
a
have my box.
generator, because you are
Yes.
changing magnetic field, changing, let's just write changing flux generates current,
Oh wait, hold on. All right.
right?
Let's
What
actually.
we had to do is kind of
So
rotate it from
this
outside,
is a lot to do with the
but
first
if we
day.
can rotate it outside, then it can generate current for us, right? So this is what happens in windmill, where a wind or water can turn this right
A
externally,
full
and but because of the
hour.
change of flux, you are able to get current out of the dam or the
I
windmill.
want to see the. I want to see the full period,
That's one
bro.
key idea. Yeah, you should try to find which point the flux is maximum and flux is minimum.
Show me
And
that
induced
harmonic
EMF will
motion,
be the
baby.
exact opposite of this. So if the flux uh, changes here, so here it is exactly perpendicular, right? Maximum flux or minimum flux, right? So this is
Yeah.
maximum, this is minimum. But at this point, zero
Well,
EMF is produced because
guys.
this
Well,
represents the
here
slope
it
of this
is.
graph. The slope here is zero
Should we
and
just
slope
bother
here is
looking at
zero.
it
So
now?
induced EMF here is the least, but in the middle,
I guess
induced
that's
EMF is the
another
max
item off the list.
when it's changing. Just like so, you should try to understand these things in more depth. Okay. And the last concept in this chapter that we'll see is transformers.
Boom. Money well spent.
The idea behind transformers is you have one coil
Oh,
and
we can. Oh, it lights
you have
up. We can
another
actually
coil
come here.
which is more
I died.
densely packed. Right. So if this n is 10, this n is
Oh,
say
this
100.
is a nice.
Right. So what you do is you pass uh, current from one side, and this current is AC current. Right. So it flows like this, then it flows like this, then it flows like this, then it flows like this, alternating current. This is something
What?
we'll see in the
You
next
know
chapter
what?
also. It changes direction, like up, down, up, down, up,
What?
down. And because of this, so sometimes it acts like a north-south where it tries to generate field like
Taking over
this,
the web?
and
What?
the next moment it switches polarity and becomes south-north. So earlier it was like this, it switches
Say
polarity and then becomes
how?
opposite. And because of
This is
this,
new.
so
Oh,
this is the primary loop
wait, this is not
that is
Neo. This is
driven
new.
by current.
What the fuck?
Right now, through flux linkage, at what we can call just
There
magnetic
we
field,
go.
in the secondary coil, this is the secondary coil, the red one, right? In the secondary coil, flux changes, right? Because of this oscillating behavior of current, and because of this flux change, you will see that
Guys,
a net
what the
current
fuck?
like
This is
this,
what
and then like this, and then like
design
this,
like
and then like
this?
this. Similarly, you see a current here, right? So in a way, you were transferring current here, but it got
No, that's
transferred to the
Neo
other
who's
side,
the one
right?
It
Because
clearly
of this
says
flux
so in the
linkage.
caption.
So you might ask, what is the advantage? What happens is, if we had put 5 volts here,
Yeah,
because
you
this
can
n by
actually do
n
that.
ratio, that same 5 volt becomes 500 volts here.
What
Because
the
there is a
fuck?
factor of 10 here from here to here. So there will be a factor of 10. So not 500, it will
Alright.
become 50 volts here. So
Quiet.
between them. So that is the advantage. So transformers are used to step up or step
God damn.
down the voltage. So that is another key concept.
64.
So take it up or take it down,
Uh,
right? So
okay,
what
alright, that's enough
changes, what
distraction,
remains
guys. That's enough
constant on
distraction.
both sides is power on the primary coil.
So, I think we
Let
should
me,
go to take this photo.
let me write
And
this
then
on
go
the
home.
next one.
You know, it's actually quite concerning that in like
So what
9
changes
or
is
10
the
this video,
voltage
the
of
street is
input
fucking wet.
a primary coil. Let me just write it as V primary and V secondary is not same, but
The full
say
experience.
there is n
Is it
primary here,
actually called Vancouver? Or is it
which is
you
the
saying
number of
that?
loops on this side, and n secondary, right? So we talked about that uh, the ratio of
Oh.
how it steps up, right? So the voltage that's
Actually,
induced
Abe
in secondary
completely
by
told me
voltage that
that
is
it
in
can
primary,
always
that is
be
dependent on the
verified
ratio
in 1864.
of the secondary to primary. Let me verify that formula once.
Cat.
Right. Anyway, so the ratio remains the same. So if the secondary number of coils remains the same,
Gotta be a
but
cat.
power on the primary coil, which is
Fuck, it's not a
I
cat.
I primary into
Wow.
V primary, right? I n times V is electrical power.
Cat
That
feet.
remains the same in
Cat
the
feet.
secondary coil. This is I secondary to V secondary. Now, because you know, say in the previous example, NP by NS was
Yeah.
10, right? And we saw that,
Other hates cat
say the
so we should go here.
primary was 10 volts, so V secondary
I'm
was
adding to the
10,
list. What?
say this was 5 volts.
What?
So then that gets stepped up
Cat
by a
feet.
power of 10, right? But on the other side, if the I primary, say it was say 1
Don't you
amp
like
before,
cat hair in your
it will be stepped down in the ratio of this. So as a result, if you check primary power,
That's actually really
that
impressive.
was equal to 5 watts. And if you check secondary power, right, that's also equal to 5 volts. And that needs to be the same. So
No pets
power
right
remains
now.
the same, but voltage gets up
The
and
whole
down,
point is
but the current also goes up and down. So power is what represents how much energy is being transferred, right? And you can't create or destroy energy. That's the conservation of energy. So this can't change,
okay.
but you can always step up and step
Another
down
strap.
voltage.
I'm just
Why we do
supposed
that is another question. We'll talk about that in the next chapter, hopefully. But it's useful when you want to transmit voltage from like 200 kilometers, and so you have to step it up,
I'm actually very
transfer, and then
disappointed.
at the other side you step it down. So there are two sides of transformers that are used. Okay, I think the chapter was a little bit like on the surface level how I taught. It will be very helpful if you can do the question, the
Alright,
20 internal question that I talked about.
gas down, Muji. I
Okay,
think this should be
yeah,
enough
just attempt those questions and we can discuss your
investigations
questions.
to hit up.
Okay, sounds good.